Okay, we have a combination of x, y, and z here and a multivariable function, and we'd like to create a contour map for this. The contour map are curves that we get when we set z equal to different constants. So we'll pick z equals 0 to begin with, and that gives us the equation x squared plus 4y squared equals 0. That equation only has one solution, the point 0, 0. There's no other way to add numbers together to get 0 if the numbers are positive, which they are here since they're squared. So on our contour map, the only point with height 0 is the origin. Let's move on to something more interesting. If z equals 1, then we have x squared plus 4y squared equals 1. This is an ellipse. So all of the points, the set of points, or the collection of points at height z equal 1 is an ellipse. If we take our surface and we slice it at z equal 1, the slice that we get is elliptical. We can plot the particulars of the ellipse by looking for the intercepts, which is a good trick. Just let x equal 0, then we get 4y squared equals 1, or y squared equals 1/4, so y equals plus or minus 1/2. So if x is 0, y is plus or minus 1/2. Let's put those there. And if y is 0, then the intercepts we get are x squared equals 1. We get x is plus or minus 1. So those are the intercepts we get. We can draw the contour now, and it is an ellipse. That's the ellipse that we get. We'll do one more. Z equals 2, we get x squared plus 4y squared equals 2. Again, I will do the trick of intercepts. If y equals 0, then we have x equals plus or minus the square root of 2, which is like 1.4, so that's a little bit further out on the x-axis for those intercepts. And if x equals 0, then we have y squared equals 1/2. So y equals plus or minus 1 over the square root of 2, which is like 0.7. So that's the start of our contour map, right? What we have here, that ellipse is the set of all points at elevation 1, and the other ellipse is the set of all points at elevation 2. This is the topo map for our surface, or the contour map for it. Each line is a line of constant altitude on our surface, and this is the trick we use to represent 3D surfaces on a 2D plane.